Hello everyone, welcome back to another episode of MATLAB programming. In the coming videos, we're going to dive deeper into selection statements in MATLAB and learn more about the if, else, else if, and switch statements and see how these logically true or false statements can help us to drive the program in a certain direction and make decisions that are necessary in many practical examples out there. Since we're familiar with the general structure of the if function statements, let's start our example and explain that in more detail. I have created a script that saves time. Let's call it decisions. And then we're going to start from here. So the problem in this, the first example, so let me put it this way. Example 1 would be write a program to ask the user to enter a number and then calculates the square root of the number. Okay, so we're going to write a program that asks the user to enter a number, and then we calculate the square root of the number. Seems very simple. So we're going to expand it a little bit and see how many situations or what type of situations we may face. The first one would be that the number is positive, and we can use the sqrt function to calculate the result. The second situation is that the number that user enters is a negative number, and we cannot calculate the negative number, the square root of a negative number. Therefore, we multiply it by -1 or calculate the absolute value of it and then continue the calculation. And the third scenario would be that the number is 0, and of course, the sqrt of 0 would be 0, and we're going to tell the user which kind of situation we're facing and what decision we took. So let's get started with that. First, I create a variable called num, which stands for number, and then I ask user to enter a number. Enter a number. And then we start the if process. The first scenario would be that the num is positive. That's the easiest way. And then sq, or better say sqr, the square root value would be the sqrt of num, the value that the user entered. And then fprintf, the square of the num is, we use floating point, and then let's put it on the next line, and of course the value of sqr. That would be the first scenario. And then the next one would be else if. Why else if? Because we're going to write a program for more than 2 situations, for more than 2 logical results. We have num larger than 0, num equal to 0, and num less than 0. So we have more than 2 situations. So if num was less than 0, it means that it's negative. We're going to use num equals num multiplied by -1, or num equals absolute value of num. You can use both. So let me actually put it this way. Another way of making absolute value. And then after this step, we calculate the sqr equals sqrt of num and this num is now positive. And similar to that, we use fprintf. The square of the num is float number n on the second line, and then we of course use sqr. So that's another scenario. And the last one would be else. It's that when it is not positive, when it's not negative, it has to be 0. So we simply use fprintf of the square of the 0 is 0. And of course, the last would be if we start the if, we end it too. So that's the whole program. Let's try to run the program and see the result. Okay, so enter a number. The first scenario would be a positive number. The square of the num, and I'm consistently typing the wrong here. Okay, thank you. Alright, so let's do it again. Okay, so the square of the number is 3.46, and it's a positive number, right? And remember that you can use who, and it tells the values and the variables that you have here. So you can actually calculate see the value of the num and sqr that we just calculated. Let's get again with a number, and this time I'm going to use a negative number. The sqrt of number is 3.46. So that's when we reversed or made the number positive and then calculated the sqrt similarly. And then the last situation would be that if it is 0, the sqrt of 0 is 0. So you see that how easily we divided the program into 3 different scenarios, and then for each one we wrote a separate lines of code that when that situation or that logical value comes true, those certain lines would run and the rest would be ignored. In the second example, we would like to run a program that checks if an entered number by the user equals to a series of numbers, and then depending on whether one of the numbers matched the original input, then we display a certain text. So let's call it number match program, and then let's start with A. We call it input. Enter a number. We ask the user to enter a specific number, and we call it A. And then we test the first scenario, that would be if A equals, let's say 10, the first value, and then if the condition was true, then we use fprintf the value of the input is 10. Okay, so that was the first scenario. And else if A equals 20. If it was not 10, let's say, else if the second case that was 10, or the second case that was 20, then we use fprintf of, let's put this way, we can copy paste this. 20. And then there's another scenario too, else if A equals 40, then it would be 40, of course. And let's do another one, else, and that would be if none of the values matched the input value. And in that case, we simply show it in a text format. None of the values matched the entered number, and then end. We completed this and let's run. Okay, so enter the value, let's say 12. None of the values matched. Let's have 20, and you see the value of the input is marked as 20. Also, I changed the formats and put all of these values into parentheses. For those of you who was wondering why the first was not, the 810 was not in parentheses, it's arbitrary and you can put it in different formats. For example, I can actually take out all these values and then still the program manages to run and generates the results. Okay, so this was a simple example that covers multiple scenarios using else if and entered value. In the third example, we're going to solve a project which is simple but a little tricky. So here is the question. We're given two numbers and we're going to find the numbers between these two with the increment of 1. There are two scenarios. The first, that the numbers that are given to us, the first one is smaller than the second one, and it's easy to sort the numbers in between. However, if the second number is smaller than the first one, we have to switch the position. And in between, it gets tricky, because once we're going to switch the position, we may lose one of the numbers if we put them equal to each other. So let me give you an example here. If we want, let's say A, the first number is 2, and B, the second number is 5, and we wanted to find the numbers between them, it is easy. We can simply sort it between 2 and 5. However, if A was 5 and then B was 2, we wanted to switch the position. So we might, and it's very common pitfall that you will see in a lot of examples. So you might say, okay, that's easy. I get B equals A, and then now I've switched the position. However, I don't have any A's left to work with it. So if I go with B, the value is 5 and A is 5. There is no 3 left that we can, work with. So the solution is that in between we should introduce a temporary variable and then we use that as a medium to switch the position. So before I solve this example, I would like you to actually pause the video and try to solve the project by yourself to your own creativity, and then get back to the solution and see how we did it here. Of course, this is not the only solution, and down the road we get introduced to more complex functions that will resolve such issues. However, for this step, I think it's a good idea that you do it yourself and then get back to this video. All right, so let's get started with this example. So finding the numbers between two integers. Okay, so I would like to introduce the mean. The first value is that I'm going to ask the user to enter it. Enter the first number. And then the second one would be max equals to input enter the second number. Okay, now we have two numbers here. So the first scenario would be if min is actually less than max. Okay, in this scenario, the output would be min max, right? The numbers between minimum and maximum. So this is case 1. Minimum or first number was smaller than the second number. And let me put, say, first number min was smaller than second number, which was max, right? Okay, so that would be the first case. And then else if min was actually bigger than max. And that's the case that we run into problem. So in order to avoid the pitfall that I just showed to you, we can introduce a medium variable or temporary variable called temp or whatever you like. And then we make it equal to the value of the min. So now, and remember, in the second case here, let me put a comment here, minimum is actually the larger number. Okay, so when we put temporary to minimum, it means that temp is now the larger number or actual max, right? Because we used temp as a temporary variable, and since the minimum here is the larger value, now temp is maximum. All right, so next we switch the value of min and max, and this way we don't lose the value of minimum because we already put the value of minimum into temp. We have it there, we store it. So now we switch the values of min and max and lose the minimum value. It's okay because we have it in temp. And then the last step, we put max as temp, which is because the temp has the value had already the maximum value, right? Okay, we switch the values of the min and max and lose the value of min, and temp had already maximum value, so the max becomes actual max. And then the output would be min max, and then end. That's it. So we wrote this program, and let's now try. We don't have any specific error, and let's have the first scenario would be that the minimum or the first number is smaller than the second one. So I use 3, and then 17. Okay, so let me actually get rid of this. Okay, so let's have 3 and then 17 again. So this is the values sorted exactly as we wanted. And now the second one would be, let me use different numbers here. I use the first number 16 and the second number 5. And now this is the second scenario. And it will switch the numbers and return them in a sorted way. As I said, later we work with the sort function and we can accomplish this in fewer lines, but this gave us a good intuition to how switch values and avoid pitfalls. Thank you very much, and I'll see you in next video. In this example, we're going to learn the switch statement, which is very useful in programming in multiple, actually it's used in multiple programming languages, and specifically MATLAB. And switch statement is very similar to else if and if statements, and we use it when we wanted to test one entry against several possible examples. And it's often easier to work with instead of the else if and if functions, and I'm going to demonstrate this actually situation using two examples. So the first one would be that I solve a project using the conventional else if and if functions that we learned previously, and then I'm going to switch to the next possible solution, which is using the switch example, and we're going to compare them and see the result. Okay, in this example, I'm going to ask the person or a student to enter a grade of the student. And then depending on the grade, we're going to show or reply back some sort of input to the user. So let's get started with that. I'm going to define a function. I'm going to define actually an input variable called grade. And in this, I'm going to ask the student enter the student's number. And if you see, when I use single quotation or apostrophe, it just messes the function. So in order to resolve it, you can use two of these, and MATLAB understands that we're going to use like a grammatical situation and ignores the error. Okay, so grade, input grade, that would be, and since we're going to enter a string or a character, we have to specify for the input what type of input we're using. In this case, it's a string. So if grade equals A, then printf student's grade is C, because it's character, and then excellent job, and then use grade. And let's do this. At the end, I use the next line. Okay. So in case A, printf. Okay, now it's correct. Okay. In case that the grade is A, the user will receive a response that is an excellent job. And also I forgot to put 2 semicolons because it's a if situation. We're not sure if the grade is A. And then else if the next situation would be that the grade is equal to B. And then we can actually copy paste the whole thing here. And in case that it is B, it's also excellent job. Else if grade equals C. And in that case, let me copy paste it again. And then we can use well done. Else if grade was D, then we can use try harder. Oops. Try harder. Else if grade was equal to F, then use the same thing. Try again. That's when the student is actually failed. And I'm going to consider another scenario that something else rather than these options is entered. And let's have else, that would be f print f invalid entry. And of course we end the program. Let me use this one here. As we saw, we just created some sort of program that classifies the student grade and then shows the result back to the student. So let's use this one. If A, excellent job, perfect. B, the same thing. C, student grade is well done. D, student's grade is D, try harder. And let's use E, which is invalid grade entry. So it works perfectly fine. Also, since A and B are kind of similar or identical actually, so we can use OR function B in here instead, and then make the whole thing a comment. So what I did is that I combined case A or case B, and if I use it A or case B, I get the same result. So you're able to use the one that you prefer. You can also use OR function, which does the same thing. So this was the case where we used if and else if. Now we're going to switch to the switch function and see how that one compares to this program and if it is shorter or better version of it. Okay, so let me close this one, and then I'm going to copy, paste, and then instead of example if, I'm gonna use switch. Then grade example, get rid of that. So instead of this one, I use switch. Okay, now I'm going to switch back to the other case. As you remember, I mentioned that the switch is used when we want to compare one entry against a lot of examples. And this is very similar to our case in here. The format for the switch is that we use switch function. It's a reserved actually word. And then we use case, for example, case 1 and then action 1, case 2, action 2, and so on and so forth. So let me actually get rid of this. We can use a lot of it, but I prefer to write on a clean sheet here. All right, so the first one would be the same. The grade is the same. And then I'm going to switch. It's a reserved word, grade. Okay, so when we switch, it means that we're going to use multiple cases in here. And let me close it too. Every switch comes with an AND, exactly like if and else if. So the case 1, case A, we would use printf, similar to previous version. Students grade is %C, excellent job. And then of course grade. Let me close this one too. And then the next one would be case B. Going to use the same scenario. Excellent job. Then case C. And then going to substitute that with well done. Case D would be try harder. And then case F we try again. And finally, instead of the last section, which is, if you remember, we had else if, else if, else if, and else. In the case situation, we have case, 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 and otherwise. Otherwise, it's a optional input to this function. We can get rid of the otherwise, but in this case, I would like to use it so we can see that it's exactly like else, else, else if. We can use the same scenario here too. Excellent job would be, there would be, of course, no other entry, and I use it as invalid grade entry. Then, okay, so everything seems good in here. So let me get rid of this grade. And then it looks fine. Let's run that. So A, the same thing. B, C, D, and F, and E. So you see that exactly we accomplished the same thing, the same result with probably fewer lines of code or more simpler version of the program, and you can compare these two. It's good to know how to work with both of them, and it's definitely worth learning this type of programming as well. Hope you enjoyed this video, and I will see you in the next one. In this video, we're going to write a program using the switch function to find the original review of a movie based on the average rating of the people who watched the movie. So for example, we wanted to enter a 5, 4, 3, 2, or 1 rating, and then the program should tell us it was originally a review of 2-star or 5-star movie. It's very interesting and practical example. So let's get started. I'm going to create a script. I'm going to call it rating value. Okay, and in here, this function finds the original review of a movie based on the average rating of the people who watched it. Okay, and the first scenario, similar to the previous example, we're going to define the invalid case. So if rating is less than 0 or rating is more than 5, it means that, well, the rating or the review is not correct, because we can actually put a note in here that the standard rating is between 0 to 5. Okay, so anything below 0 or above 5 would be considered as invalid. And then I consider one AND for the if, and inside we can put, okay, so if the rating was less than 0 or 5, then the review would be invalid rating entry, or entry. That's fine. So we get rid of this entry. And then else, now we're going to switch to switch cases and see how they're useful. Switch rating case 5. Okay, switch rating and case 5. Rating and let's case 5. It means that if the rating was 5, then review was a 5-star. That's the first case. Now let's go to case 4. The review was a 4-star. Case 3, review was a 3-star. And then case 2, review was a 2-star. In case 1, review was a 1-star. And also we consider otherwise case, which means anything else. Review would be no review was given, which includes the 0 case. For example, a rating of 0 means no rating was given. 1 AND for switch, and 1n for f. And then let's close this. We have one error in here. So we have one and extra in here. Actually, what we can do is to turn this one into a function. Let's do that. What I'm going to do is to use function review equals rating value and then rating. It means that the name of the M file should be rating value as it is in here, and the input argument is rating, and the review is the output. And then we need one and in here for the function. So one and for function, one and for if, and one and for switch. Okay, so let's see, we don't have any type of error. Save it, and let me close this. Alright, so rating value of a 5-star. Review was a 5-star. Rating of a 4-star. 3, 2, let's see what happened to 2. That's not star. 2. Okay, we have a misspelling here. Okay, good. Now, so let's rating value of 2 and review of rating value of 1 and rating value of. Now let's consider the 0 case, which was not in here, and no review was given. And finally, let's consider the invalid cases, something like -2 or above 5, 6. So invalid rating entry. Very simple, we could write a program that could find the original rating of a movie based on the reviews of the people who watched it, and then you can expand such simple algorithm to other cases as well. For example, you can expand it to finding the grades of students or finding the quality of a product in a factory, and there are a lot of similar situations that you can use this algorithm for. Hope you enjoyed this example, and I'll see you in the next one. In this session, we're going to know a new function called menu. And this function is very interesting. Similar to input function that we can ask the user to insert a choice number, we can actually ask the user to select his or her selection using mouse click on a graphical interface. And it has a lot of uses and examples in the industry, and let's get started with a quick example. I'm going to create a new script, and I'm going to call this sensor selection. Okay. In this example, I'm going to ask the user to select which sensor should be chosen for reading data among, let's say, temperature, pressure, and flow. Okay, So we have three sensors: a temperature sensor, a pressure sensor, and a flow sensor. And we can read data from these sensors, but the user should select which one shall be actually selected for reading data. So first I'm going to write this using if, else, if, and then we switch to switch function and do it that way as well. Sensor, I'm going to call this sensor selection equals, and instead of input, I use menu. Menu, you're able to put multiple inputs in it, but you should follow the format. The first is the menu title. As you see, menu should have a menu title. What do we want that menu to be called? Well, I want to call it select, and this is arbitrary. You can choose whatever you like. Select the sensor to read data from. That's the title that will be shown. Next, what is the first sensor? Let's say pressure sensor. What would be the next? That would be temperature sensor. And then what would be the next one? Would be flow sensor. Let me actually put this one. Temperature sensor. If you remember, we can use 3 dots when it is a long statement, and it will bring it to the next one easily without any type of error. And we forgot a comma in here, so there should be a comma between the choices. And then let's go to if selection. If sensor selection was equal to 1, we can easily display data is coming from pressure sensor. And then else if sensor selection choice was the second one, this data is coming from the second one would be temperature sensor. And then let's have else if sensor selection was 3, then this data is coming from the flow sensor. And then finally we can have else, in case that none of them were selected or the menu is closed, we can have no sensor is selected. Finally, we close the end function. Since we don't have any type of error in here, let's run the script. Let's see what we get. Variable sensor selection is also the name of this script. Oh, we selected, okay. So I deliberately don't eliminate these kind of errors, so you could see that sometimes we forget simple things. The reason to this problem was that the name of the sensor, the name of the M file, is also a name of variable, and it's illegal in MATLAB category. So let's rename this example 1. Okay. Now, when I run this script, you see that MATLAB gives us a graphical interface that you can select. Let's go with the pressure sensor. Pay attention that the pressure sensor was the first choice in menu. So if I select it, now the sensor selection would be 1. And a data is displayed. That data is coming from the pressure sensor. Let's do it again. This time I select the temperature sensor. Same result. And then flow sensor. It's very useful and you can expand the idea into multiple scenarios. Also, let me run one more time and show you something. If you by any chance close the menu, no sensor is selected and the sensor selection value is 0. Now that you have an output for this, you can use it as a logical variable. For example, we can use if the sensor selection was 0 instead of 1, then follow such and such. We can expand the idea into multiple categories. Now let's do the same thing using the switch. Let me close this and then create a new one. I put this example 2 because it's very similar. I'm going to use a lot of it. Using the switch and example 1 using the if. Okay, so let's get back to this. We don't need example 1. And instead of this, I can say switch sensor selection, and then in case 1, this one. Case 2, which is the temperature, then display this one, and then case 3, display the flow sensor, and instead of else, use otherwise. So pressure sensor 1, temperature sensor. We got an error in here. Let's see what is that. Case 2, 27. I see, so we need a standard space. Let's do case 2 is okay, and then case 3. So you can actually compare the two in here and see what is the difference between these two examples. Using the switch, it seems that it's simpler code and with fewer lines, so it's your personal preference what type of programming you choose, but I just wanted to show you that there are multiple options for you in here. Hope you enjoyed this one, and I'll see you in the next video. Hello everyone, welcome back to another episode of MATLAB Programming. Today I'm excited to share with you a big project that we're going to do together, and we're going to use a lot of the things and techniques and functions that we learned so far and create something very useful. This project is very important, and I wanted to ask you to pause the video after you see what's the question and then try to solve it yourself, but later get back to the video and see how we're going to actually program it and to create it. As I said before, there are millions of ways that we can write this program and solve this project, but this one is very comprehensive, so I hope you find it useful, and get something useful out of it. We're going to create something called the BMI index. So BMI index is body mass. So BMI, this one stands for body mass. And so what is it? The body mass, it actually shows, it's a number. It shows the relationship between a person's height and weight. It can tell you whether you're underweight, you're normal, you're obese, and to what level. So we're going to write a program in MATLAB that, first of all, asks the user to give the height and the weight of the body of the person, and then calculate the BMI and suggest to user what type of body he or she has and what they can do about it. Let me start by specifying the BMI formula. BMI formula equals mass in kilogram divided by height in meter. This is the SI unit. This is for SI. Also, we have BMI for imperial units, which would be mass in pound, and then height in feet. Multiplied by 4.88. So there's a conversion, right? There's a conversion between these two units of measurement. And if you're wondering where that 488 unit came from, please note that 1 pound equals 453, almost 59 kilogram, and 1 feet equals 0.3048 meter. So these are the conversions from pound to kilogram and feet to meter. And if you look at the formula, and I forgot to put this one into square too. This is in a square. So if you refer to the formula in here, we have BMI equals weight multiplied by 4. I'm using these coefficients up there. 4, 5, 3. And then 1 feet is equivalent to 0.304 multiplied 0.304, because it's a square. And then the height in meter. So I converted the BMI. The BMI used to be in pound and feet units, and then I converted it into BMI in kilogram and meter. So if you calculate this portion, that equals to 4.88. That's the conversion unit. Let me create a new slide in here. Okay, so Now we wanted to receive the input from the user about his height and his weight, and then calculate the BMI. And we have the BMI formula. One important factor is that there are different criteria for determining the shape and the status, the health status of a person based on the BMI. But a type of a standard one is that if the BMI, which is calculated, so the BMI will be calculated from mass and height square, and if the BMI is less than 16.5, then the person is, if the BMI is 16.5, then it is severely underweight. If the BMI is between 18.5 and 16.5, the person is simply underweight. And if the person is between 18.5 and 25, that person is considered normal. From 25 up to 30, that person is overweight. From 30 to 35, that person is obese. And we call it level 1. From 35 to 40, that's obese level 2, and 40 above, that person is obese level 3. Let's have 40 as this level, 30, 25, and then 18.5. So we make it equal. These are some of the criterions. There are different ones too. For example, there is another one. It's instead of 18.5, that's 20. But for now, we're going to consider it as 18.5. So this is the formula that we're going to develop. On top of that, we wanted to make the software or the program intelligent. We wanted to run the calculations in two different modes, for SI units and for imperial units. And then that makes it more practical. Okay, so without further ado, let's get started. Welcome back to this episode of MATLAB Programming. Today we're going to write a long program and project based on the information that we got from the BMI index. It's going to be a very long kind of program, and there are a lot of things in there that we're going to try and learn, hopefully run into different problems and resolve them one by one. And I do my best to kind of try different methods to do to achieve the results for the things that might be repetitive. So you see that there are different ways to handle the program and still get the result. With that said, let's get started. So I'm going to give a title to this. Program title would be BMI calculator. At the beginning, I would like to welcome the user to this program. We can say this is a BMI calculator. Welcome. This is a BMI calculator. Okay. And then we can give a new line in there to give some space. Then, based on the information that we had, we do have two types of calculations in here. One for SI calculations, one for imperial calculations. First, I'm going to do the imperial, and then later we move to SI standard. One way to differentiate between these two is to define a variable like unit, and then I ask the user what type of calculation they want to have, imperial or SI standard. So enter 1 for imperial or 2 for SI units. So the user will tell us what type of, calculations they want. And then in here we say selecting the unit of measurement. Since this is a long program, I highly recommend that you exploit the commenting feature in MATLAB and use it frequently, because we're going to have a lot of line of codes. So if I run the program, okay, enter 1 for imperial, 2 for SI units. So instead of units, I would like to have standard. Okay. So let's say 2. If I put 2, the value of the unit here changes to 2. If I put 1, the value would be 1. Later, we will use this variable and then use it in the if scenario and do calculations based on that. This is one way to do it. Another way that I would like to show you is through the menu function that we learned. So the menu asks for a title and then option 1, option 2, and so on and so forth. So standard selection table, and then option 1 would be imperial. It should be all imperial, and then option 2 would be SI standard. Okay, so that's another way to do it. Selecting the unit of measurement in using the GUI. Okay, so that's another way. Let's do it here. When I run this, MATLAB pops up a GUI, and look at here, the unit is 1 currently. If I selected the SI standard, the value will change to 2. So this is another way to do that. It is up to you, arbitrary. You can select whatever method you prefer. And let me use that one here. After this, we need to collect information from the person to see what type of weight they have, what's their height, and then build up on that. So we can ask the user weight variable, input, enter your weight, and since first scenario we're doing it in imperial, that would be pounds. Weight, and then the next one would be height variable, input. Similarly, we have enter your height in feet. Please make sure that you observe the capital letters at the beginning of these variables. This is very important. If you don't observe it, you will run into error. So the weight with capital W and height with capital W, we consider those. And then in here we said get information from the user in pounds. Get the information from the user in meter, in feet. Okay. And now it's the time to calculate it. Calculate the BMI. BMI then equals to weight divided by height squared make some space. Okay, so weight divided by height squared. And remember, since we're using the pound and feet unit, the BMI will now have a coefficient too, 4.88, that we discussed how we calculated, we came to this factor. But since the unit of measurement is imperial and the lbs and feet are the measurement units, we need to consider the 4.88 as well. So in here, we consider 4.88 conversion factor as well. So that's the BMI. And in here, I would say calculating the BMI units, lbs feet. Okay, that's the BMI unit that we calculated. So let me run up to this one. Weight 186, feet is 6. Okay, so we got the information in here. One thing that would be really useful is that we calculate the minimum weight and maximum weight that a person can have and still be considered healthy. So let me show it to you in here. This is the formula for BMI. It is in kilograms, but it's simpler to start with this one. Look at this green line. This corresponds to the scenario where the BMI is considered normal. So 18.5 is the minimum BMI and 25 is the maximum BMI. This 18.5 corresponds to a certain weight, because this is not a weight, this is a number, this is a measurement. But this 18.5 corresponds to a certain weight. We call it W mean. This 25 also corresponds to a certain weight that we call it W max. W max and W mean are the weights that a person can have and still be considered healthy. This is the maximum weight and this is the minimum weight. For example, if you are 186 pounds and then the doctor tells you that the maximum weight that you can get based on your height and still be considered a healthy person, not obese, not underweight, is, let's say, 190. So you are 186, and 190 would be your maximum W max. And then the doctor tells you that you cannot be lower than 170 pounds. If you are less than 170, then you are underweight. So 18.5 in here would correspond to that 176. Now we wanted to find that mass. What is the ideal mass? What's the range? So it's very easy. For the minimum, if I put 18.5 instead of this BMI, just consider that 18.5 is here. And I wanted to find the mass. The mass for the minimum would be BMI of the minimum multiplied by square of the height, right? Similarly, the mass for maximum is BMI of the maximum, which is 25, multiplied by square of the height. Very simple. So I'm going to do that here. However, in our case, since we're using the lbs and feet, we have a coefficient too. So for the minimum, BMI is 18.5. We want to find the mass. 18.5 multiplied by the square of height divided by 4.88 would result the mass in pound. For the maximum BMI, 25 multiplied by a square of the height divided by 4.88 would result the weight of the max that one can get. So let's get back to program. In here, I would have W min would be 18.5 multiplied by height squared and then divided by 1.88. Okay, I did the division using the multiplication, but I reversed the number. So that would be the minimum weight. So let me put a comment in here. Minimum weight a person can have and still be considered healthy. W max would be 25 multiplied by this, right? That would be W max. And similarly, we can put it in here. Maximum weight that the person can have and still be considered healthy. Very good. So all these calculations are from here are for imperial case. So what I can do, I can use an if in here. If unit was 1, so the user has selected unit, right? The unit is 1 or 2. If the unit was 1, then all these calculations will be done. Else, if the unit was 2, there's some other calculations will be done that we'll discuss later. Let me put an and for the if too, so the structure is now correct. You can verify it by looking at this green light in here that specifies everything is correct. Okay. So in here, the unit was 1. It's a good idea to display it to the user too. I can say printf, make it line, then printf okay. So I want to say that this unit is selected. So I need a string, because that string corresponds to imperial or SI. Unit of measurement was selected. And then that would be imperial. Put it in single quotation because that's string 2. So now if I run the program, enter 1, imperial unit of measurement was selected. Enter your weight in lbs. Okay, so what I can do is to disp some new line in here. So if I run it again, 1. So in here, let me make a space. 180, and then fit would be 6. Do it one more time. Okay, now it went to the next line. Actually, I can put 2 of these. This to make room for both of them. Okay. Okay, now it's better. It gave some more space in there. I can name this part getting users information in imperial units. Okay. So based on this, we got the information from the user, weight, BMI, and mean and max. It's a good idea to show to the user the information too. So what I can do is that tell the user the information is fprintf your minimum healthy weight is, and then in here I'll use %.2f. Let's have W min. That would be the minimum. And similarly here, I can use W max. That would be the maximum. Right? So once we calculated the minimum and maximum weight that a person can have and still be considered healthy, is this value. So let's do it. So 186, 6 foot. I tapped it too fast. 86 and 6 foot. Okay, so your minimum healthy weight is this, and your maximum healthy weight is this value. Let me see. Here I can put this. To make some room. It's better to put pounds, units of pounds in here. So 186, 6 foot, and now better. your minimum healthy weight is this, your maximum healthy weight is this. And also, it's not a bad idea to show your current weight as well. Print f of your current weight is %.2f. And then simply the weight that the user has entered. Current weight of the user. Okay. So 196, that's fine. 6. Okay, so your current weight is this, your minimum health weight. Let's put this one in here. Okay. Current weight is this. Even I can put some more information, the BMI, the user. Okay, so your BMI is percent and then BMI. Current BMI of the user. That's it. So we completed the program up to this part. So 180 and 5.5. Okay, your current weight is this, your BMI is this, your current weight, your minimum healthy weight is this and that. Perfect. We calculated this value. Okay, so we did this part. What else we can put in here is that the user has selected the imperial, so it's not a bad idea to show your measurements will be in imperial lbs and feet units. Because he has selected 1, we can actually disp this. Okay, so your measurement will be in imperial this, and since we have put this line inside the unit 1, which corresponds to the imperial, that would be fine. Let's play and let's have this, give some space in there. All right, perfect. And let me show you another way to write this fprintf, because I've seen a lot of programmers do that in MATLAB programming, and that might confuse you a little bit. So let me demystify that in here. You see that instead of, a lot of people use disp a lot, and one of the benefits that we learn about fprintf is that you can you can have a lot of control over it. You can use numbers, strings, and everything in there. And like this is not limited to the strings. So the format for the disk is that inside the single quotation, we should put a string there. Imagine I'm going to get the same result I did with fprint with this. So your minimum health is, and let me, for now, put it like that. In here too. Okay, so if I try to type your minimum health is this and put wmin in there, let's see what happens. You run into error because this part is a number, but this part is a string. They don't match. So one way to resolve this issue is that to convert this wmin to a number too. I can achieve that using a function called num to str. And all it does is that converts a number into a string. Okay? So this one is no longer a number, it's now a string. However, this does not resolve the issue because now the format of the disk is not correct. Everything in this should come together inside this single quotation. In order to resolve this issue, we use brackets to combine them together. We can combine things inside, like if you have, let's say, 2 and 4, then they come together. The answer is 2 and 4. They come into one section. They'll be shown together. The similar way is to doing this. And now we have a text shown and then another text shown in here. If I wanted to show the pounds, the unit of pounds, I can use that in here too. So I achieved the result similar to the above method using the num to str. So let's try that. If I want 1, LB is 180, 9, and then feed 5, your minimum health is 97,746, right? So we achieved the same result. Let me remove this section. And then run it again. 170, 166, feet is 5. And then you see that the healthy weight is this. We achieve the same result in 2 ways. So with that one said, let me use this in here too. This time I will make these lines commented. So it's up to you which one you choose, but just notice that you achieve the same results in both ways. Okay, so we have calculated everything up to this part, and it is the time to start the program. I will consider a section for this BMI calculations in Imperial, LBs and feet. Now we wanted to do the calculation. Remember that we're still inside this if. Everything we're doing here is inside the imperial calculation, imperial section. So what we're going to do in here is to model this table, BMI less than 16.5 between these two numbers, and so on and so forth. We're going to model that. So let's get us started. If BMI was less than 16.5, then the fact that you are severely underweight, please visit a nutritionist. ASAP. Okay, we wanted this to be shown to the user, and then this some space here. Now, if you remember, we calculated the W min and W max, right? Where's that? W min and W max. The W min was the minimum weight that a person can have and still be considered healthy. There is something that we can do here, a very useful thing, is that we can tell the user how much weight they should gain or lose in order to come to this range, normal range. So for example, we're talking about this scenario, this situation where the person has a BMI less than 16.5. If he is able to gain weight until his BMI becomes 18.5 or more than that and less than 25, that makes him a normal person. So we want to tell him how much weight they should gain. I can use printf, and in here I would say you need to gain minimum %.2f lbs and maximum %.2f lbs. Okay, and then what would be the range? Because the person is severely underweight, the minimum normal weight is larger than his current weight. So W min minus weight of the person is the minimum weight he can get. And then W max minus weight of the person would be the maximum weight that the person should get and still be considered healthy. This is the first scenario. The next one would be else if the BMI is more than 16.5 and it should be less than 25. Should be less than or equal to 18.5. That was the next range, right? So when we put things inside this format, it means that the AND, it's a logical AND. It means that this case is only true when this one is correct and this one is correct. So the BMI should be larger than 16.5 and less than 18.5. Less than or equal 18.5. So in this scenario, I would say you can use the same thing in here. Copy instead of typing. you are no longer severely, but you are still underweight. Please see nutrition is not as soon as possible, but you know, at your convenience. It's better to do it because you're underweight. And then you need to gain minimum this amount lbs and maximum this amount of lbs. Here still this one applies because we're still talking about a person with the underweight situation. Still this formula, the W mean is larger than the weight of the person, and W max is also larger than the weight of the person, so that works fine. The next scenario would be else if I'm going to use that. Okay, else if BMI is more than 18.5 and it's less than 25. Okay, if you remember, that scenario was for a person who was normal, right? Okay, so I put this. And one thing that I would like to do is that to ident things in here, make it easier for later to see what we are doing. Okay, so this is the normal. You are, you can say normal, keep up the good work, and then give some space. We don't need that because that person is within the desired range. Okay, so the else if the next scenario is, let me use this one actually, or this one. Okay, and this. Okay, so here is for the person larger than 25 and still less than 30. And that scenario was overweight, if I'm not mistaken. Yes, overweight. Okay. You are overweight, please be more active. And then you need to here lose minimum this percent and maximum this amount of pound. And here pay attention that now we're talking about a person who is above the normal range. The minimum weight that the person can get then becomes W max minus weight and W min minus weight. Just look at the code in here. We're talking about this person. So the minimum weight that a person should lose would be the difference between this number, lower range, to this number, lower range. So this upper range. So this 25 corresponds to W max. This 25 corresponds to the weight of the person. So that would be the max and current weight. This difference is very small. But this number and the weight of that person has a bigger difference. So that's the maximum range that the person should lose weight. Okay, so that's this scenario, and this should be weight minus weight min with max. This is reversed. Weight minus weight. Weight of, what do you mean? Now it's correct. Okay, because now the weight of the person is larger than the weight of minimum, and the weight of the person is larger than the weight of maximum. For the next scenario, we have the same thing in here. Let's make some room. Okay. So else if now above 30 and less than 35, you're obese level 1, please see a doctor. And then you need to minimum weight, maximum weight. That's going to be the same for all of these scenarios. Okay, so above 35 and less than 40, you're obese level 2. The best scenario would be when we have BMI more than 40. You're obese level 3. Okay, so that's the way to do it. Now we have if, and we need one end. We have one error in here. Let's see, 87. 87, yes, we don't need that one. And we handle this situation for this case. Let's see. Okay. So we wrote the program so far. Let's run it. Okay. We have written only for imperial. Your measurement will be imperial. Let's see, 190 and 6 foot. Your BMI is 25.76. Weight is 190. Your minimum healthy weight is 136. Okay, so we found one mistake. Your minimum healthy. Okay, we probably BMI, your current weight, your minimum healthy weight is this. This should be your maximum healthy weight is max. We forgot to correct it. So let's do it again. 190 and 6 feet. Oh, where's one different? Max. Okay. That's W max. 190 and 6. Okay. So minimum, maximum overweight, please be more active. Lose minimum this amount and maximum this amount. Okay. So we did it for the scenario, and I encourage you to run multiple scenarios in there. For example, keep the height of the person similar and then do the increase the weight. So you just step up into these levels and find the scenario that matched your case. Okay, so far we have done everything in Imperial. Now that we're okay with this, we're gonna copy everything up to this point and put it after, let's see if, right? So else would be unit of measurement for SI units. It starts from the else. Okay, so that's the part, and I can actually separate it SI unit measurement section. Then, okay, get rid of that. That would be SI unit, and then everything with pounds should be meter. Pounds would be kilogram, and then feet would be meter. And we don't need this conversion rate anymore. We only need it when the unit of measurement one was in Imperial. Okay, so this was now kilogram. It's better to put it in here too. Okay, so that was LBs. Back to this section, BMI. Get rid of these conversion units. We don't need them anymore. This is kilogram. This is kilogram and meter. Try to, be consistent and find every unit in here. That's kilogram, that's meter. Okay, that's good. Kilogram. We don't need that factor 2. Okay. And kilogram. In here, okay, and everything is okay. That would be kilogram and meter. Please make sure to change all of these. If I forget to change something, you do it yourself. I did my best to find all of them, but I can't see anything more in here. One more item that I would like to show you is that, if you remember, we used one if, else if, else if, else if, else if, up to end. However, if you consider some space in there, else space if, okay, so let me use that. Else if, okay, so now I separated the else ifs. If you see that this case is shown, make sure that you provide one end per if in here. So end, 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 and end. 1, 2, 3, 4, 5, 6, and one more for if. Yeah. So I wrote the program in two different ways. For BMI calculation in Imperial, I leave it like else if. For SI unit, I leave it like this. Both will result in the same thing. Okay, so red, and that's the end. You can say this. Of the program. Okay, so let's see the result. There is no warning or mistake in there, so that works. 2, okay, weight in kilogram, 89, height 1.8. You can do this in centimeter too. You have to, consider a 100 conversion factor there. So your current weight is this, your maximum healthy weight is this, your minimum is 59, your maximum is 81. Your overweight needs to be more active. You need to lose minimum 8 kilograms, a maximum 29.6 kilograms. End of the program. I suggest that you play with this code and change it. And one more important request that I have from you is that once you felt pretty comfortable working with this code, try to write the program for yourself, the question for yourself, and then try to program it from the start, from the beginning. There are many ways that you can write this program, but I want you to try it by yourself after you're done. When you run into error, that's how you learn. That's how you pick up the programming. And make sure that you try different things. Do not stick to one method that you learn. Be more creative. This is just an example that I put together, but you are now in a position to really be creative and write very, very advanced programs. Hope you enjoyed this project, and I make sure to include more useful ones in there, and I see you in next video. Thank you. Hello everyone, welcome back to another episode of MATLAB Programming. In this video, we're going to start a new project, a simple one, but it's very effective and it helps us to use multiple skills that we've used so far. So one item that I wanted to mention here is that the simple skills that you develop during these simple exercises or other projects, they're not very different from the skills that you need to build a very large and complicated program or app out there in MATLAB or any other programming language. Once you totally understand and internalize all these skills here, it would be much more easier for you to use them and utilize them in various and more complicated projects out there. With that in mind, today we're going to write a program that finds the prime numbers under, let's say, a number. Let's say the prime numbers under 100 or 1000 or any specific numbers. So before we start, I would like to show you one way to actually group the files in here. As you see, some of them are in functions, some of them are in scripts. So if you click here and then under group by, there is a grouping category called type. If you click on that, now MATLAB selects the adds-on, the functions, and the scripts separately. So that makes it easier, especially for this program, that we're going to write a script and then change it to a function and call it multiple times. So before that, let's get started with the definition of a prime number. So n is a prime number if and only if it has exactly 2 divisors, 1 and itself. Okay, so 1 and itself. It means that n should not be divisible by any other number than 1 and itself. So it means that if you wanted to see a specific number, if it is a prime number, what we can do is to divide it by 2, 3, 5, 7, so on and so forth, and see if the remainder is 0. Or one easier way is that we just need to check the n to see if the n is divisible by 2 and radical n. The reason is that, let's say, a number, let's say like 9. Okay, so 9 is 3 by 3. So radical 9 will be 3. It means that we're sure that there is no more or no other number larger than 3 that 9 it will be divisible by. So any number that we have, we only need to check it by 2 and radical n. If the remainder of this division is 0, then we're sure that it's a prime number. Now let's try to model this in MATLAB. In order to find if a number is a prime number, we would like in the first step to ask the user to enter the number for us to check. So I define a variable called n, and then input, enter a positive number, better say integer. Ask the user to enter a positive integer in here. Now I create a index called I, and I wanted to put it up to sqrt of n, right? That's the way that we wanted to check. We said that we're going to check the numbers between 2 and sqrt of n. That's all we need. At this stage, imagine that number n is 14, okay? And if I calculate the sqrt of 14, that would result to a number with some decimal points. And that's for sure, we know that there is no prime number with the floating point. We all need integers. So here I would like to show you a function called floor, and I put sqrt of n in here, right? The n is 14, or let's make it simple here, 3.717, okay, something like that. I wanted to check that, and if I hit enter, that rounds it down to 3, right? I can actually use duck floor, and this will bring up MATLAB documentation. And here you see that the floor, it needs 1 argument, rounds each element of x, that here we only have 1 element, to the nearest integer less than or equal to the element, right? Less than or equal. So that rounds it down to 3. There is also another function called floor, and I put 3.717, that actually I put 417 that we used previously with floor. Now I use it with sale, and if I do that, it will round it up to that one. So I can also check sale. Here it will round each element of x to the nearest integer greater than or equal to this element. So for sure we know that we can't use the sale because that would round it up to a larger numbers, right? For example, here we have 14, but if we round it up, we for sure know that 4 by 4 will be 16, which is larger than the original number. Instead, we use the floor to bring it down to 3. So in here, I use floor of sqrt of n, and now it will round it down. So in here, what should we do? The way that we can check if 2 numbers are divisible is that to check the remainder, right? If the remainder was 0, it means that those 2 numbers were divisible. So this is what we're going to do. We're going to ask the user to give us a number, right? And then we will create a range of numbers starting from 2 to sqrt, floor of sqrt of n. So in this case here, 2 to floor of sqrt of 14, that's an example, would bring only 2 and 3. It means that if you wanted to check that if 14 is divisible by, if we wanted to check that 14 is a prime number, we have to check from 2 to 3. We have to create this and then do what? Divide 14 by 2 and check. If the remainder was 0, it means that that number was not a prime number. And then we discontinue the loop. But if 14 was divided by 3, the remainder was not 0, it means that it can still be a prime number. We're going to check it with the next number. So it will, with the first one here, with the 2, the 14 divided by 2 will be 0, the remainder will be 0, and then we know that it's not a prime number. So there is a function in MATLAB called mode, doc mode. All it does is mode a and m, so it gets 2 arguments, input arguments, and then returns the remainder after division of a by m. So it will divide a by m and then show the remainder. That's all we need. So in here we say if mode of what number? If mode of n and I, if mode of n and I was 0, it means that for sure this number is not a prime number. Okay, we know that it's not a prime number. If mode was actually 0, we should come out of the loop because we found out that this number is no longer a prime number. Before doing that, it's a good idea to change the status of a variable and mark it as a flag that, hey, we found that this is not a prime number. So I create a new variable called prime and put it 0. In case that this mode was 0, change the status of the prime to 0. So at the beginning, I would put prime to 1. It means that at the beginning of the project, I will imagine every single number is going to be a prime number. And I check it. If that number was not a prime number, I will turn the status of that variable to 0, from 1 to 0. If that number was indeed a prime number, the prime value would stay as 1. Because we're doing a logical calculation. We're going to check if that n number is prime or it is not a prime. So a very good way to do it is using a variable and then check the status of it as 0 and 1. Here, flag that shows the n was not a prime number. Okay? So when this one happens, do we need to check for the rest of the numbers? No, because we could find that it's not a number. In case of 14, 14 was divisible by 2 because the remainder of the division, 14 by 2, is 0. So we don't need to check for the 3 as well. We have to come out of the loop. In MATLAB, when you define a range and then you just want to check one by one, and if the situation or the condition is not met, you don't want it to check for the rest of the loop. The way to come out of that loop or condition is to use a function called break or a command called break. So all it does, it will jump out of the whole thing and comes in here, out of the loop. Here there are two things that we're going to check. If prime was 1, indeed was 1, okay, was 1, then fprintf of the number was a prime number. We know that it was prime number if the status was 1. What if it was not? Else, then we can use the whole thing in here and then was not a prime number. Okay, and then end. We close the program. That's it. It's going to check for every single variable that we put into the MATLAB. So let's check that. We start by 14. Was not a prime number. Very good. Let's go with 15. It's not a prime number. Let's go by 11. 11 number was a prime number, was or actually is. Okay, one more time. 11, and that's a prime number. And this is a very effective and simple way to check if a number is a prime number. There are, of course, various ways that we can check to see if that number was a prime number. In the next example, I'm going to show you another way, a more efficient way to check that. But before doing that, still we can do a very good thing here, and that's to convert this program to a function. Now let's change that, actually create a function and test our program in a function format too. So all I can do here is to create a function, and I call it output, and the name of the function I call P1. All it needs is a argument, input argument that we provided with, and then end. That's it. And once we want to save it, we save this one. MATLAB automatically saves the name as P1. It should have the same name. Let's go back to the program that we had here, and we get rid of Actually, we need all of it. Let's bring it back in here. Okay. And okay, now let's check the result in here. I call this program P1 and then give it a number 14. Enter a positive integer 14. So it's better to get rid of actually this line of code. Okay, then one more time. P114 is not a number. Another one we check at 100. Check it, it's not a prime number. Let's go with 13 is a prime number. So you see that now in any program that we have, if we can simply call this one and it will return the result. So this was one of the ways that we can use the function to facilitate and expedite a long process. Thank you very much, and I'll see you in the next video. In this video, we're going to show you another way to find the prime numbers. So, second method to find the prime numbers. Okay. So similar to previous example, I would define a variable called n and ask the user to enter a positive integer. And then I would define a for loop, and I define two indices. A equals starting 2, because that's the first prime number, to n, the one that user enters, and then I end it here. Again in here, I use for second in this, which is b, equals 2 to n, and let me make some room. So if I calculate the mode of a and b, if the mode of a and b was a number other than 0, okay, if it was a number other than 0, it means that that number might be a prime number. However, if the mode was actually a 0, it means that these two numbers were divisible together, right? They were divided like 4 and 2. So the mode would be 0. And then we're sure that that number is not a prime number. So I will simply make it a not of mode of a and b. If that happens, break. We know this is not a prime number. How? Imagine a is 5 and b is 3. What is the mode of a and b? That's 2. And what is the not of mode of a and b? That's 0. Now imagine this one. A is 4 and b is 2. What is the mode of a and b? That's 0. And what is the not of mode of a and b? That's 1. So in case that those numbers were divisible, like 4 and 2, the result of this expression becomes 1. Similar to here. The result of this becomes 1. So, and 1, if you already know in MATLAB, 1 represents true. So if the mode was true, okay, we can use true or false. If the mode of a and b was the result of this was 1, it means that if it was true that their division would result in a 0 remainder, then break. We're sure that they're not prime numbers. So it will jump out of the loop. And here, I define another loop. It's a nested if loop, right? For b larger than division of a and b, f print f the n number, let's say like that, n is a prime number. The second line goes it, and the index would be a, because we're going to go to the next one and check that one too. And okay. So it will start by 2. It will get a number from the user, and then it will create a range from 2 to n, right? For example, if n, let's say, is 15, then 2 and n becomes this range. It will define the range in here, and a similar one to that one too. So the similar copy of this. And then it will divide one by one. So 2 by 2, 2 by 3, 2 by 4, 5, 6, and then checks the mode. If the mode was not 0, it will jump out of the loop. And then if the b, the second row, the result, the b itself, was larger than the division of a and b, that means that that number is a prime number. We already know that this condition, if that applies, the number should be a prime number, because the mode was not 0. So those with, let's say, 4, 6, 8, and then 9, because it's like a 3, it will be checked by the next one, 2 and 3. So every one of them, which is divisible, will go away. The ones that stays, if the condition of the second row is larger than the division of the first row by second row, that means that number is a prime number. And we'll show it in here. After this one is done, then it increases the next one. This 2 becomes 3. So the 3 up to n, and then the loop will circulate until all those permutations are done. So let me run the example in here. Let's go number 14. So 2, 3, and it's better, so I suppress it here too. So number 14. Okay, 2, 3, 5, 7, 11, 13. Perfect. It's something like 29. So all the numbers, and then did it twice maybe. Okay, so that's the prime numbers. Shown in here. And depending on how large the number that you enter, that calculation may take some minutes, or not minutes, but seconds. So let's go with, I can use a function called actually tick, and then at the end tock. Okay, tick and tock. It's like a clock, tick tock, something like this. So it will measure all the time it takes to run these lines of codes between these two expressions. It will calculate it actually. So let's go with a number like 13. So elapsed time is these seconds. Okay, and let's go with something larger than that. Okay, so for this number, the result would be this, and let's run something else too. You get the idea that you can measure actually performance of a calculation using this method. I hope you enjoyed this example too. So try to, improvise and create some examples for yourself. And make sure to include some practice examples and also projects for you. And that will help you a lot to develop the skills you needed in MATLAB programming. I will see you in the next video.